All right, welcome. We're here doing our engineering technology podcast with ProLytX, hosted by me, Mike Antosh. In the studio today, I have David Wicker, longtime colleague, programmer extraordinaire, and safety system expert. But I'm going to let you give a little bit of background. So David, tell me about yourself.
Sure. I'm Director of Technology at ProLytX. I've been in instrumentation automation industry for about 19 years since I came out of school. I worked as a safety instrument and system engineer for a system integrator for about 11 years, and then really got involved developing tools, technology to make my job faster. Then when we started ProLytX, really just got involved in developing new technologies to help our clients and to help us internally just do work a lot faster.
Okay, so developing tools to make your job easier. We had some history working together. I guess, what was the first, did we start working in Access, Microsoft Access?
Yes, and Excel, VBA.
A little Access, Excel, VBA, Visio, SQL, VB, C#, and now AI, right? Okay. Now, there's a whole story there that we can go through a little bit of that history. But today, we wanted to talk a little bit about AI. It's a huge buzzword in the in the world. And as we've watched it progress, here recently, it seemed like everybody all of a sudden had AI. Right out of nowhere, there was valid AI. I think that's because some of the technology is being sourced by the major technology providers like Google and Microsoft. Is that correct? Like, what do we know about that?
Yeah, so I don't know. It catch us by surprise because we had tried to do a lot of things in-house and just never had the capability until the last couple of years. We saw that explosion. So we're at ProLytX not involved with the development of the AI technology itself. It's really more how to make use of that and how to extend it for application to our customers and our industry.
Okay, and we've looked at it. While AI is generally talked about in a sophisticated terms like how it's impacted self-driving cars, how it can be used in the medical industry to detect diseases and situations. But from an office standpoint, I mean, we've been working together since 2003 or 2004. It hasn't, there had been no impact that I had seen to our day-to-day work. Is that correct with you?
That's right. And we're dealing with clients that have still literally filing cabinets full of pieces of paper with handwritten marks on them, and they're operating their facilities every day off of these documents from the 80s and 90s a lot of times. Sometimes they've got databases and digital systems, and we're trying to help them move into that world. But we were trying to figure out how can we make use of these really advanced AI tools, but still provide value to our customers who are not living in that world or even close.
Well, and we had been watching the technology, waiting to figure out how it could impact office life. How could it impact the tasks that we do every day? I think you mentioned, and it's one of the things that we're going to talk about is we as a company help people build a digital twin, like a digital version of their plant, whether that be a refinery or a chemical plant or a renewable fuel plant or anything out there in the energy business, I guess. And in order to run those effectively, you need a good set of blueprints for the facility. How was it designed? How is it running? Feedback from the actual day-to-day, and that needs to come all together into a digital solution so that it's not just hard hats and boots, right? Because if everyone every day is just walking around with a wrench and a screwdriver looking for something to adjust in order to keep the plant running, well, that's not going to be allow us as a society really to run efficiently enough to get the the emissions down, and to run safely and do all that. So everyone's looking to build a digital version of their plant. And we often see that being done with sophisticated tools, tools that people may know like SAP. That is a business software to help run a major facility like that, or smart engineering tools, databases, data-driven things. The question that everyone runs into is, how do I get all of my information into that? If I have a filing cabinet full of old blueprints for the plant, drawings that were used to construct it, and now I have a new tool available to me that can help me run a better digital plant, how do I bring all of that legacy information into my digital twin? Because the term digital twin that's a relatively new term. People have dabbled with it over the years, but we haven't really seen it in terms of efficiently managing the data behind an operating facility. We haven't seen that come to prominence until recently. And so one of our areas as a business, I guess, is bringing in older file formats, PDF, Excel, drawings, bringing those things into a smart format, right? And we've been trying to do that through years with technology, data extraction technology, programming data out of an address, a delimited file, like out of a text file, out of a spreadsheet, maybe out of an Access database or something. We've also attempted OCR type technologies in the past, right? Yeah. So what's been your experiences with some of that progression of data extraction over the years?
Yeah, especially with the older OCR technology, it was just really a disaster. We knew if we could reliably get the text information out of a document, we could do a lot with that. Save a lot of manual effort. And we perform all of our services here in the Houston area. We're not farming things off to other countries. So we need to be efficient, and we can't have an engineer sitting down for weeks and weeks and weeks manually typing in data from a document. But OCR was really a disaster. It was so unreliable that the results were almost unusable. Every now and then it would do a good job, but then it required so much quality control and manual effort to fix it. It just wasn't workable.
So OCR, explain that for the audience.
It's optical character recognition. So that's software that understands what letters look like and can read writing. It might be electronically generated. The results are a lot better, or it might be handwritten. But basically recognizing those characters through computer vision and then translating that into text.
So in the data world, when someone comes to you with a extraction question, the best case is it's in a database of some type, and right. You just have to translate it from one database to another, right? And then the second best case is it's some type of text that's already in a format, a repeatable format that you can program out of it. But OCR means
you've got an image, right?
It's basically looking at it like your eyes would look at it, right?
You've got a PDF maybe that is not electronically generated. The text is not embedded. It's essentially a picture, and you're trying to get the text out of that document. As a human, you can look at it and obviously read it and pull the text out. It doesn't even require a lot of extra training, but it's time intensive. But yes, we especially have to deal with hundreds of thousands of these types of documents. They're not in the ideal scenario. It's not an Excel document. It's not a database. It's not something you can easily pull the information out of. And we've got to pull the information out, and we've got to put it into a digital format.
Okay, so that you're at that point now where you're looking at optical recognition, and then the harder case there too is it's handwriting, right? So you've got it's hard enough as it is just to pull a scanned document that was printed at one point, and now you need to scan it and make sense of it. Mm-hmm. But sometimes you are looking at actual handwritten documents. So an old data sheet from a pump that was purchased or designed years ago, or a markup, a drawing that went out to the field and someone redlined or marked in new values, right? Yeah. So the industry struggles with this idea of digitization because of volume and because of format and because of unstructured information, right? And so when someone comes to us and says, build us your digital twin, we have been limited primarily by the structure of the data, right?
That's right, yeah.
Now, AI, though, so we pose the question, how is it beginning to change what we do as a business? We think there's some technology here that we've been able to leverage that's really changing that game and shifting what we can do there. Is that right?
Yeah.
Okay. So we're going to go through, generically, at a high level, everyone's heard ChatGPT recently. The explosion of AI has been documented pretty well, and I don't think we have to dive into that too much. It's just we've all seen that, it's AI's ability to take standardized tests or to interpret language, or even now create fake podcasts. As all of a sudden just boom, because there really wasn't a lot of that publicized. Like it was, I guess it was being worked on, but it really wasn't all that public. And now it has accelerated quite a bit, right? So when we talk about AI, tell me a little bit more. What are we really talking about?
So when we say AI or artificial intelligence, really you're talking about computer systems that are able to perform tasks that would normally require a human, okay, to put it simply. But we know from looking at them, they're rapidly improving, and they're reaching, if not already there, at human level intelligence in a lot of areas. But we know that they're not perfect. So our struggle then is how really do you make use of that? And there's another AI term, if you will, that more closely aligns with our internal strategy called augmented intelligence. This is where you're using AI, but you're using it not with the aim to actually replace the humans in the process. You're using it to augment their capabilities and to make them more efficient and faster at doing what they need to do.
Okay, so our current aim is the right mixture of AI with human approvals and review in order to get value. Because we're not talking about something here, you can take a video on your phone and use AI to, change your face or change your haircut or something. But here we're talking about engineering documents that were created to construct an important facility that needs to run safely. So the augmented intelligence piece too fits in nicely with that story, because you get to take advantage of everything that you can, but also involve engineers to be able to review and approve, as much as possible.
Yeah, because if you read a 2 as a 7, that could kill somebody, right? We're not talking about, like you said, like changing someone's face or making a cute video. We're trying to translate engineering data, and we need to ensure that that's done accurately. So regardless kind of the automation target you're aiming to achieve, humans need to be in the loop to validate that data before it hits its final resting place.
Yeah, and we'll get better and better with smaller reviews and lessons learned and training the model. But we still, for the foreseeable future, we're still talking about engineers having a part in this process. Just, there's man-hour costs, there's different labor strategies. How do you build a team that can compete in the global market? Like you said, we do most of our work here in the Houston area, so we're attempting to use resources that we can give a competitive advantage and still fit into the box that we have to fit into to be competitive as a business. So I think we're going to talk through 5 steps that we go through that use this technology, and the end result is the ability to basically take a scanned document from an engineering facility, feed it through an AI engine, and have a product ready, have a digitized transformation into one of those big systems that's running a digital twin, right?
That's right, yeah.
So paper into the digital twin. So
Sure.
how do we get there?
So I'll walk through 5 phases. This is our internal strategy that we're out there trying to show people, and as we're continuing to evolve both our tools, technology, and strategy, I think we want to have an open conversation with folks about what makes sense and what this looks like. So from an augmented intelligence standpoint, really the first phase is using AI. This is where you want to capture as much value out of the box with commercially available tools and technology that doesn't require a lot of manpower effort going and configuring things. Basically, in essence, we want to be able to hand a chunk of documents over to an AI and hit the ground running with what it comes back with. So internally, we've selected Microsoft Azure. We use something called intelligent document processing to do that first pass analysis of the documents and to come back with the text in the documents, their locations, and automatically identifying key value pair information, tabular data, and the like as a first pass.
So you use a couple of acronyms there. So the IDP is Intelligent Document Processing.
Yep.
So that's an offering from Microsoft using AI to do that initial recognition of the document, and it's really geared toward PDFs. Is that correct?
Right. Yeah, and they have
kind of skips the Excel, Notepad, text files type world and says,
yeah, well, folks like us, we have solutions for those type of documents, right? That's not been a struggle over the years, but PDFs, images, things like that, it's difficult. So yeah, they jump right into that. It's focused on PDF documents.
Okay, and you used another acronym I was trying to think of there. I can't recall. But IDP, so that's phase one. Basically, there to be able to give it documents that we haven't done anything with.
That's right.
And say, tell me what you find, right?
That's right,
Is that right? Okay. What's step two?
So intelligent classification, like an automatic classification of documents. In our world, that looks like tens of thousands, sometimes hundreds of thousands of documents that you don't necessarily know what you have. Maybe someone has gone through, owner-operator has hired a company to come through and just scan thousands of sheets of paper that are in these filing cabinets, and now they want to move that data somewhere useful and then discard all of that paper. So if you're going to do that, you don't want someone opening up each document to figure out what it is, what it looks like, and how to organize it. You've also got duplicate documents, all kinds of things, just trash in there that you need to get rid of that you don't really care about. So what we do is, now we're talking about what we're layering on top of the artificial intelligence that's out there. So we have technology that will correlate the information that the AI gives us out of the documents and auto-classify the documents. So finding similar bits of information and similar structures within the documents themselves, correlating that between all the documents, and then coming up with different categories. It's not going to necessarily know exactly what the document is, but it can tell you, hey, these 200 or 300 documents have a very similar structure. So that's kind of the next step for us is doing that analysis and that auto classification.
So that's when we begin to put our own spin on AI and make it into the ProLytX AI engine that we're building. So to back up just a sec, if you wheeled in a filing cabinet here full of engineering data papers and said, Mike, we got to put this into our smart system. The first thing I'd have to do is get somebody in here to sort it out and figure out what do I have, right? Is it 1,000 of the same document, or is it a whole bunch of different stacks of different types of documents? And in our task in our industry, that's been an unavoidable part of the process, I think. Is that right?
Absolutely, and it takes a long time, sometimes weeks, to go through tens of thousands of documents and figure out what you have and try to put them in categories that you can give to a team to actually start working with. And we're not even talking about extracting the data at this point. This is just figuring out what
making a plan, right?
Yeah.
And so what we've talked about so far, IDP and then our ProLytX intelligent organization, is really plugging into that file cabinet and saying, okay, AI, what do I have in here? And how many types? I got types and quantities, right? Basically, I'm going to divide it up into stacks. So how many stacks do I have and how big are they? Because when you're going to migrate something like that, the small stacks where it's a onesie twosie type thing, You don't really worry about that from a programmatic standpoint, right? You're looking for the big value. Where do
Right.
I have bulk that I can automatically work with, where I can create a data set and use it? So so let's say I roll in this theoretical file cabinet with 1,000 files in it. How long does it take AI to tell me what I've got?
Well, I'll use an example. We had a project with 10,000 specification sheets that we needed to migrate. We processed those through AI. It took about 30, 35 minutes to do the initial analysis with AI and get the results back. It took another 30 minutes to actually classify those documents, put them into different buckets. So out of 10,000-ish documents, we ended up with approximately 150 different categories that it had automatically determined based on the content and the structure of those documents.
So 150 stacks that added up to 10,000 individual items, and that was done in an hour.
That's right, yeah.
And in our business, we estimate things by the man hour. So the concept of giving someone 10,000 items to sort is not a task we would estimate in an hour.
That's like a 3-week job.
Yeah. So there we're off to a good start. And like we said, our goal here is a practical explanation of how we're using AI. And that's a real case. So I remember now what it was that I forgot to say earlier, and that is you use the term key value pair.
Right.
And so for the audience, I want to get as wide of an audience as possible here, David. So
Sure.
I'm not going to assume that everybody knows exactly what all these acronyms or different terms are, but and we're talking a key value pair. We're talking about the type of document where there's a header, like a row, and it's got a title and it's got a value, right? So location and a value, and manufacturer and a value, right?
Material, like any kind of piece of information you're looking to pull out. It's got a header and a value.
And sometimes those things could be, one line in the document has one header, one value. Sometimes you could have it split up into 2 headers, 2 values. Sometimes it could be vertical, other times horizontal. So what you're asking, what AI is able to do for us is look at that and say, I think these 2 bits of data belong together. This manufacturer and this value, rows mount, those look like a pair. And then this model number and this text and this number, those look like a pair, right?
Right.
Okay.
So then the question is, well, how good does it do? So if you're talking about its ability to actually recognize text and extract textual information out reliably without typos and correctly identifying even handwritten text, it's on the order of 95+% good at actually identifying the text and pulling it out effectively. But secondarily, if you're talking about how effective is AI at automatically determining those key value pairs, depending on the quality of your document and how well structured it is, what we're seeing is approximately 50%.
Okay, so we're seeing that market improvement on the OCR. That's
Yes,
on the ability to process the text.
Yes.
That's just drastically different than we had seen in the past. And then the ability to make a logical determination of a value pair is something typically the programmer would have to do, right? Line 17, first value, second value type programming. And so now that hour where we took that filing cabinet and we plugged it into our Magic AI robot, what did we have to tell it before we gave it the filing cabinet?
Nothing.
Nothing.
Yeah.
Okay. We just said, tell me what you find, period.
Yeah.
Okay. Awesome. Okay. So we talked about intelligent document processing, being able to just take that first pass. And then we talked about taking the results of that from our standpoint and organizing it into stacks. So now here we are. I've taken my 1,000 items from the filing cabinet. I have stacks laid up on the desk, virtually, digitally. What do we do next?
So the next step is actually train it for extracting the information out. Here's an interesting note. So when we were walking down this path, originally we thought, hey, we'll take these commercial offerings. They offer you the ability to train documents. We'll just go in, we'll figure out what we have, we'll train the documents, and then we'll get out a really good extraction, and that'll be usable. Turns out that's not the case. Not only does it get significantly more expensive to do that, it's long-winded. So you have to provide multiple documents, very similarly structured, and it takes a long time with the commercially available tools to go in and actually train it for extraction. You'll see a slight improvement in the quality of the results that come out, but it's not really usable for us. So quickly, we realized we need a phase 3 to this approach here. We need to actually come up with our own system that we layer on top that allows a subject matter expert to really train the extraction and work directly with the data. And that's what we've done. So I talk about augmented intelligence. This requires visualization then of the document, both the document itself and then a layering over top of that of, for example, the key value pair information that AI came up with and all the other textual information that's there that AI didn't know what to do with. We present that to the user in a visual interface that allows them to go in and adjust it. So starting off with what AI gave you and then tweaking it, adding the additional key value pairs that it missed and adjusting the ones that it got wrong in a visual, like, quick way.
Okay, so we're at the training part, right? Which sounds cool, right? We're training the AI. But what I heard you say is there is a way to do that with the standard commercial offerings. However, we found better results by putting our own layer of training on this. And we're giving the users a head start. So it's not that you're training every cell on the document, right? You start with basically the launching pad of what AI was able to give us straight off the bat. And then we just allow the subject matter expert to just basically polish that and finish it. Is that right?
That's right, yeah.
Okay, awesome. And we have a video where we're going to show a little bit of that training, right?
Yeah.
Okay, great. And then essentially now we've gotten to the point where we've pulled everything out of the filing cabinet. We've stacked it up. Now we've trained on each template what we need to do. Now we're at the point where we want to digitize that essentially, right? And so that's a pretty simple step, I guess. Is that right?
Simple from a user standpoint, very complex behind the scenes, right? So now we're dealing with how do we actually build a system that allows a subject matter expert to quickly train a model for extraction and then apply that to a series of documents that, we've auto-classified these. You've trained a model for each category. Now you want to apply that and actually tabulate all the results.
And what you're actually doing is, so this theoretical stack that adds up to one template, if you're reviewing those one by one and looking at the results, it's tedious. But if you put them all in a grid and you say, okay, I had 100 that were this type of piece of equipment, and I've extracted all the data and I've put it in this simple grid, you can see the outliers in that, right? And that's where the engineer, the human comes into play a little bit again, is to say, okay, do I see anything here I want to investigate? With the translation up front or the way that I mapped it or whatever. Is that correct?
So that brings us to our phase 4, which we call extraction and QA/QC. So that's actually doing the extraction. So the software that we have in-house, it will apply that template and tabulate all your results. And then we take the subject matter experts and they go through and then they do quality control. So one thing, if there are any typos, if there are any errors in the extraction itself, now you're tabulating hundreds, in some cases, thousands of documents of similar type. And very often, through review of that tabulated result, that report, you can find those outliers very quickly. Not only that, you can find gaps, right, where you didn't get any data. And now you need to go and either decide, okay, I'm going to decouple from my AI system and I'm going to manually fill in the gaps, or I'm going to refine it a bit and try to get a little bit better results before I decouple and go manual.
Yeah, and anytime you're automating something, there's a point of diminishing returns, right? So you're just working here to that right recipe for it to get value and quality.
And before, with older OCR tools and some of our in-house technologies, that was on the order of maybe 20 or 30 documents. If you had more than 20 documents of a certain category, it was worth automating to some degree to extract that information. And now with AI, we're down on the order of 2 or 3 documents where it's actually worth the time to build a template and extract that data.
Right, because the alternative here is literally a person taking a sheet of paper out of the filing cabinet and just typing it in.
Typing it in. Yeah.
Right. I mean, because we're talking about digitizing a plant or digitizing portions of information, and in a lot of cases, that is still the solution, is to just have a stack of paper and work through them one by one, right? Which also brings into account fatigue and human error and things, and other struggles that can come along with that. Okay, so then step 5 in this process?
Step 5 is you've really got your results at this point, but for us, we're not done yet, right? We're talking about building a digital twin with AI. So once you've reliably extracted your data, you need to move into its final repository. If that's a smart plant system, for example, to use the specification sheets as an example, moving that into an SPI database. You need to actually map that data over to its home and then migrate that in some fashion. Again, as automated as possible.
Right, and that's the ultimate goal, is to get it into, you have digitized it, but have you given it the right home for the future? And that's what step 5 is doing, is moving it into that home, right?
And before, our workflow, right, it was heavily manual on the front end on the extraction. So we built tools and technologies that were very application specific, right? And we'd kind of tweak the data, massage the data, get it ready, and then pump it into its home. But now with the value that we've seen out of AI, really we're talking about a more general tool that we've pulled out separate from our normal workflow process. So we want a standard result. We want tabulation of data from which you can push that into whatever platform you'd like to have it. It's valuable just in and of itself.
And that last step, whether you're going into SAP or whether you're going into an Autodesk solution or a Hexagon solution, that last step requires you to have some subject matter expertise to know where you're going and how it's supposed to fit into that, right? And there isn't one answer there that solves that, but we've had great success taking that last step and moving it in.
Absolutely.
So we do have a video that we're going to show. It's a couple minutes long, and we may stop it a little bit and talk about it, but it goes through these 5 phases, and it'll just cap off this discussion, I think, and give us a nice closure to it. So let me see if I can get this working. Okay, great. So I believe we're going to inset this in the podcast, but tell me, we go through phase 1 here. Give me a little bit of insight here, David.
Sure. So you're watching a video, approximately 30 minutes of work in a 3-minute video. First phase, then, we're feeding documents into Microsoft's intelligent document processing.
So this is the reading of the file cabinet right here, right?
That's right.
Okay. So basically that was plugging in with no training and saying, run through all of these and give me whatever you got.
Right. All the PDFs, we feed them in about 10 or 15 at a time in parallel. And as we retrieve the results, we just store those. And then there's some pre-processing we do on our side to get ready for the next phase.
Okay. Well, then let's take a look at that next phase.
Phase 2, then, is the intelligent organization. So that's where our software is going to take a look at the textual information and the organization of all of the data and classify those documents.
Okay.
And again, it's not telling you you've got a flow transmitter.
So here we are on the video now. So it has already then taken the documents and given us these buckets, these document types, or these stacks.
That's right. And now in the video, you're seeing a subject matter expert open each category and give a name that's meaningful to that category. In this case, for this sample video, the documents themselves actually had names on them based on the type of document that it was. Most of the time, that's not the case.
And so now we have all of our stacks, and you've identified kind of a best case for each of those stacks, right?
That's right.
And so now we move into the training.
Sure. So here, we're going to allow the user to visualize a certain document. The tool selects kind of the best documents to use for training, and we're showing you a sped-up version of a subject matter expert reviewing what AI came up with, deleting the ones that didn't make sense, and then going through and adding new key value pairs to the training, to the model.
Okay. So we've got the key value pairs here. So that's what the colors represent. As you've got the header and the value. You're going through now, and you're just basically, that's where I say we're giving a head start. So we're giving the subject matter expert a head start because they're able to basically have what AI has determined and just tweak that and build the template, right?
Mm-hmm.
Okay, great. And so you're going through here.
And that's typically less than a 5-minute activity per type of document.
Okay, yeah, so an entire stack, I could have 100. I just have to go through this exercise once.
That's right.
To map it out. Okay.
Moving into phase 4, then extraction QA/QC. From a video standpoint, we're showing you the results. So really, this is a button that you press once you've trained the model. Clicking through several different tabs, you can see just the amount of information. Now, a lot of these tabs, this is completely, only one model did we actually train for this video. Most of these tabs we're clicking through, this is completely untrained. This is what AI identified and the software tabulated for us. And as I mentioned, it's approximately 50% of the content in those documents gets accurately extracted.
So here, all of this came from scanned documents that were an actual piece of paper that were scanned, and we sucked them in and got to that with very little effort.
Yep.
And then phase 5 is the move. Here we're showing a Hexagon Smart Instrumentation tool. So this is an instrument data sheet, which should be typical of something that you can see out in the industry. And we're showing here the translation and the move. So we took it from a piece of paper, and then we went all the way through the processing and moved it in, and now you'll see, we saw the blank version. Now here's the version with all of the data.
That's
so
right.
That gives an example. There, that required the knowledge of that tool to to get that in there. But that's the example of that phase 5, which is the actual move, right? And then, so with that, I think that's what, to me, that's exciting because we're seeing. You're always looking at, okay, we've got processes that are being used today, but everyone's competing. So whether that's, where your labor center is or whether that's how smart your tools are, everyone's competing. Here, we now see a competitive advantage in the realm of digitizing documents that really, We've been upgrading Excel files and upgrading Access files and upgrading text files into smarter systems, but this is now a real tangible example of AI affecting a day-to-day engineering task here in Houston, Texas, right?
Absolutely.
Okay. And then I guess with that, I think we're at a point here we'd kind of like to close this. Do you have any thoughts, I guess, where do you see this going from here?
Well, AI tools are only going to get more and more advanced, right? So it can be overwhelming. That's why we're taking a look at it. We don't want to just push off in the corner and keep doing work the same way that we've been doing it. So I see that target, that automation target of AI, just getting higher and higher, and us continuing to refine our workflows. So for us, that means just continual evaluation of our workflow and the tools that are out there. And especially there are step changes in the industry, we need to figure out how those relate to the work that we're doing and how we can make use of them. Not everything is what they say it is, right? But what we've seen in the last couple of years is a marked improvement in the quality of AI and its ability to affect our actual workflows.
Yeah, one example I heard that I thought was really good was, so we built this process to take this theoretical filing cabinet and suck it in. So now someone has a smart facility to work with. Well, now that map is built and that process is built, that could happen at a one-by-one rate as drawings are updated, as changes are made. Absolutely. To where now you're talking about the day-to-day process could be, hey, we have this one new or a small handful, run those through the system, bring them in. So this isn't a one-time value, I think. To me, this is the augmentation of that staff in order to produce an efficient plan for the long term,
Right. And right now, it's augmenting the tools and technologies that we have out there. And eventually, we can start to see it maybe even replacing some of those tools. So what exactly that looks like, I don't know. That's why we want to stay near the front of this development so we understand how to use the data and then the impact it's going to have on all of our workflows in the future.
Yeah, I mean, one of the things that we constantly hear from our clients, you used the phrase owner-operator earlier. So for the audience, that's implying the owner of the facility that's operating and has operators there every day running the control system and the HMI and doing the engineering. One thing that we hear is that staff is short, right? Budgets are short. I don't have someone available to maintain that type of document or maintain that type of system. And so as this improves, the ability to augment that staff so that they don't have to sacrifice the digitization of the plant. Because once you go from something, once you begin to use more of a paper process, even today, right? And you start, okay, well, it's too hard for me to use that system, or I don't have enough people trained, or things of that nature. It's hard to resolve that. So to me, this sounds really exciting, with the opportunity to give more options, I guess, to that plant manager or that digital manager that really wants to keep up with the latest and greatest, but is struggling with the real world challenge of just the cost of doing day-to-day business.
Yeah, absolutely.
Okay, cool. Well, thank you, David, for taking the time to share this with us. It's really exciting, and we look forward to hearing more about that in the future.
All right, thank you, Mike.